For decades, we have been discussing the concepts of how do we create efficiencies in business.
We are seeing a strong convergence of the trinity of AI. The data, the algorithms, and the compute are all coming together.
I think we're at a similar point to where we maybe were in the early 90s with the internet.
We have an unprecedented explosion of data, 90% of which was developed within the last 2 years.
We can now think about AI in a very different way, and this is the foundation of the tipping point for AI.
It has really only been recently where that excitement has turned into bottom line value for a company.
We have the opportunity now to use these pre-trained models to kickstart our AI efforts.
Most pioneers are willing to try new things. They're willing to change their organizational structure, and in particular, how business decisions are made.
We need to think big, long-term, holistically, and disruptively.
Using more advanced machine learning algorithms, we are able to save lives.
We're trying to create technology that engages citizens.
We're playing the long game. We have to reshape the way we look at our world.
We discovered that 39% of organizations were either in some phase of production or testing the technology. 0% of executives felt that their organization had no use for AI.
This is moving really fast. And one of the challenges is, how do I create competitive advantage? How do I stay ahead of the game? You need to be leveraging the best technology. What's really exciting now is that you don't need to be the size and scale of an internet giant to make AI work for you.
Sepsis is the body trying to fight an infection. That infection has got out of control and you're in a state of sort of attrition warfare.
What really attracted me to sepsis research is if you predict it early and put patients on antibiotics, you can potentially save lives. There has been a few attempts in the past 10-15 years to predict sepsis. However, many of those algorithms, they had a fairly low performance. Over the past few years, with better analytic tools such as deep learning, artificial intelligence tools, we have been able to improve the accuracy of these models. Definitely setting up the data was probably 70% of the work. It took us a year to figure out how to get the data, in what format. There were times that I thought it's just not going to be possible. The first time we built the model, it was based on only 400 patients. And our latest data pool is about 450,000 patients. With the advent of better AI algorithms, we are able to look at now many different indicators. In our latest work, we were looking at 65 different indicators. Some of them comes from laboratory, from patients' vital signs. Some of them are coming from bedside monitor data. And it's becoming impossible to process this data on our desktops locally. So that's where some of the cloud resources becomes very useful.
Shumen is one of the smartest people you'd find anywhere in the area of sort of time series analysis and deep learning. He's working much more on the AI side of things. I'm working much more on the systems side of things. In our current system, we've sort of tightly coupled how we're fetching data from bedside data sets. On the Google Cloud, we have the data layer where all the data is coming in and is being refined and getting to a point where it can then go down to the processing layer. At that stage, we found data flow ends up being a very effective tool. It's a nice managed service on the Google Cloud platform that allows me to transform data and has a very nice user interface to try and author those jobs and then reuse those jobs. Once data has been cleansed, gotten ready for computing, we make use of TensorFlow. TensorFlow is this core library that we use for developing and then deploying our machine learning algorithms. The way the overall system was developed, one of our goals was to make sure that one can easily add and develop new algorithms, such as a sepsis prediction algorithm.
Implementing the algorithms on the cloud allows us to have an infrastructure that can scale up and down. If I want to monitor 100 patients, versus maybe tomorrow 10,000 patients or even 1 million patients. The cloud gives us the ability to not worry about the infrastructure and focus mostly on improving the algorithm itself.
Nurses or the physicians can see a dashboard such as this.
At any given point in time, the score is telling us the chances that the patient will develop sepsis in the next 6 hours.
So it kind of gives somebody a high-level view, and you can quickly see or sort patients that are deteriorating versus the patients that are stable. In this particular case, the algorithm thinks there's a 0.41 risk of sepsis developing. The top 3 reasons why that's going to happen is the current temperature, the heart rate, and the chloride. Then when you kind of go into the details of it, then you see, okay, what were the trend lines? Now you're talking in the language of a clinician. You're describing what your algorithm picked out in this vast pool of signals.
A clinician, when they see a patient, is limited really to the experience that they personally have had or maybe even read about. With machine learning, what you can do is in a matter of seconds, compare this patient to 1 million or 10 million, and so bring to the clinician's attention things that are worth looking at. We were able to catch 85% of septic patients and at the same time maintain a low rate of false alarm.
Medicine is a very inertia-laden, risk-averse profession. Those of us who went to medical school, we learned how to do it the way our teachers taught us how to do it. The goal is not to replace the physician. What we're doing is giving him or her resources to make a better, more informed decision in a very quick amount of time. This is not going to be restricted to advising on sepsis. It'll be advising on who needs a blood transfusion, how quickly we can wean somebody from a respirator, who's at risk for developing an abnormal heart rhythm. And we will learn through this process what the optimal partnership is among patient, family, caregiver, and computer.
This is real. This has the potential to help real patients.
Well, like with most technologies, the early adopters are the ones who seize that competitive advantage.
You actually have to have people that are willing to experiment. Many times, companies believe that the AI journey starts with technology. The AI journey actually starts with organizational imperatives. And sometimes this requires a tremendous amount of organizational change in your industry.
I think there's no question that the combination of AI, machine learning, robotics, the Internet of Things, cloud computing, big data, these disruptive technologies, where they intersect, are going to have a completely non-linear impact on our lives. What we saw in Google Cloud was not only a company that had extraordinary engineering excellence, but also commitment to big thinking.
Ocado has always been forward-thinking. 10 years ago, no one was thinking on buying groceries online, and maybe 5 years ago, no one was doing things on the cloud. We started way ahead every time, and now we have so much data that we can use deep learning and more advanced machine learning techniques.
Online grocery is very different from other kinds of online retail. We have to contend with the 50,000 different products we sell. We have 4 different temperature regimes. We have short shelf life items. So there's a massive optimization challenge in there. And we've done that with algorithms in the past and now increasingly with machine learning instead.
Most of the stuff that we're doing, it can have an effect beyond just delivering groceries. All of our work on dextrose manipulation can be used throughout manufacturing cycles. The work done for the grid controlling the bots, you can imagine this being expanded to all various use cases.
I'm a software engineer by origin. I love solving hard problems, and I feel very passionately about building a long-term vision that looks out further than is probably comfortable. And along that journey, we also had to disrupt ourselves in terms of the technologies that we use to build our automated warehouses. We said if we're going to do this internationally, we need something that's more scalable and modular, and so we leapfrogged ourselves. Those kind of steps where you literally bet the farm, they look very sensible back through the telescope, but at the time, they're very bold and often painful. But that's what I think makes the difference. And I'd like to think that we're definitely committed to this process of ongoing serial disruption. So I hope looking back in a few years, you won't see nothing yet.
We now have access to pre-trained models in the cloud. We now have access to tools that will allow you, if you have your own data scientists or a smaller pool of talented IT individuals, to embrace this technology, create your own algorithms, run your own machine learning and deep learning models, and do really amazing things that were previously inaccessible because of cost or availability.
As the CIO for the state of Hawaii, I have one mission that the governor has given me, and that is to modernize the state of Hawaii. And that's the mission that we've been on for the last 4 years. Hawaii's always been called the melting pot of the world, and a lot of our constituents, they're not native English speakers. They feel the state's system doesn't fit them.
One of the problems that we faced is how do we make government information available to the public in the various languages that people in our population speak? Manual translations would be in the millions of dollars. And we felt that wasn't a very good use of state funds.
We stumbled across the Google API, and it did a lot of what we were trying to do.
What we're doing is we're taking all the legislative data, we're ingesting that into the cloud. It's all in BigQuery, and we're translating it in all of the languages that the Translate API supports, about 80 languages.
The Google API was a game changer. It's so easy for us to go out there and buy the application, stick it in the cloud, and run.
We really are passionate about making information available to everyone, to leave no one behind.
We are under constant threat from different natural disasters here in Hawaii. We have earthquakes, we have hurricanes. If we just tried to communicate to all of our citizens in traditional ways, we wouldn't reach everyone. And that's why these types of technology is so important.
It's showing people in Hawaii the value of technology.
Just offering those services makes lives for our citizens better. And that's why I do this job.